about Bob. Bob has 2 medium motors and 2 large motors. The medium motors are for the active attachment, and the large motors are for the movement of the robot.
Bob also has 2 medium tires and 2 ball bearings. Large tires have less accurate turns and smaller tires cover a smaller distance. We chose medium tires to help us with stability and support. They also add a balance between precision and speed. We have 2 ball bearings which help us move smoothly. They reduce friction and help us turn smoothly.
Our robot also has 2 color sensors and 1 gyroscope. This helps our robot go in a straight line. We use color sensors to align to the black line. The color sensors add precision and reliability. The gyroscope helps us make accurate turns. The gyroscope does this by measuring degrees to make sure that our robot is going straight.
For the design layout of the robot, we looked at the table map, and we also looked at the different missions. After looking at both those things, we realized we needed a robot that was small and fast. After we looked at the table layout, we also saw that there were 3 constraints. There was a constraint of time, which was 2 minutes and 30 seconds. There was a constraint of space, which was because of the pull-up bar and because of the spacing of the small inspection area. And also, because of the table map, there were lots of turns and black lines involved. So we added color sensors and we added a gyroscope.
We researched various types of robots such as the box robot, modular robot, and racing robot. We chose the box robot because it fit our requirements the best. The box robot can align to the wall, it can fit in the starting space, and it allows us to use low pin attachments which can be removed and attached quickly. For example, when doing the boccia mission, after the robot pushes the step counter, it aligns with the black wall before going under the pull-up bar.
To decide and prepare for our missions, we created a strategy matrix. In our strategy matrix, it consisted of 3 main topics: the distance from the base, complexity of our mission, and the points it will give us. For example, the bench mission had a low distance, low complexity, and gave us a lot of points, so it made sense for us to do it. But whereas something like the weight mission was far from the base, it gave us not as many points, and it was pretty complex, so we decided not to do that. Through these guidelines, we created a matrix to decide which missions we were going to do, and then made our attachments accordingly.
To finalize our attachments, we used our hands to model what our attachment needed to do. For example, for the bocce mission, we placed hands in our cubes and we slid them down to get it in the frame. So we made an attachment that did the same thing, as you can see here. And then for the bench mission, we had 4 arms, and we used our two fingers to slide them into the hopscotch spaces. So we used these arms, and when the robot runs into the lever goes down, which means the arms go down, and the cubes fall into the hopscotch spaces.
We use EV3 Classroom to create our codes. We use this because everyone wanted to learn something new. We created My Blocks to make our code modular and reusable. Even before we created our robot, we created My Blocks such as stop a black line and follow black line. This is also our Boxer mission. When creating mission programs, we use My Blocks to make them organized.
Thank you.